Hello, good afternoon, everyone. Today we'll be studying a new topic related to digital image processing that is known as image interpretation. So, from the word itself, you know that image, we are talking about satellite images, we are talking about aerial photographs, we are talking about microwave data sets, hyperspectral data sets. So all do require interpretation. So what does it mean? It means analysis of remote sensing imageries involves identification of various targets in an image. So whenever you get a satellite image or aerial photograph, that is the real representation of the Earth. That is key at what point and location, whether what land use land categories are situated. So targets may be defined in terms of way they are reflected or emitted radiation. So as we have already discussed yesterday that the remote sensing sensors record the reflected electromagnetic radiation reflected by various earth feature, and each and every odd feature has got a specific reflectance, and those reflectance has to be identified in order to get that object mapped, like what are the areas under settlement, what are the areas under agriculture, what are the areas under forest. All that has to be mapped, and that will be mapped by the reflected energy that they emit in different electromagnetic bands. So this radiation is measured and recorded by a sensor and ultimately is depicted as an image product such as an air photograph or a satellite image. So we have already stated and we have already studied that whatever data that is reflected and recorded by the sensor in the satellite will be relayed to the receiving session where all the data will be processed, all the data will be rectified, and finally we'll be comprising and we'll be composing either the soft copy of the digital satellite image or the soft copy of the or the hard copy of the image as per our requirements. So this is the way we have to do with the presentations. Then what we have to do, we have to act of examinations images to identify object and judge their significance. Like we have already stated that each and every object has got its own reflectance, and we have to identify those objects in order to get that evaluated. So each and every object has got its own keys. The keys are tone, texture, shape, size, element association, location, and on the basis of which we'll be extracting the information, and finally an interpretation will be done, and depending on your objective we'll be classifying the entire satellite image. So, an interpreter is a specialist trained in the study of photography in addition to his own discipline. So, generally, we the professionals who have got a doctorate or anybody who's coming from geography, geology, forestry, you'll see that many generally in MTech civil engineering, you will be seeing the persons who have studied BTech civil engineering are generally pursuing the course. But when it comes to our MSc or MTech program, you'll see that the persons from various disciplines like computer science, forestry, mathematics, physics, chemistry, geology, geography, all are admitted to our course because GIS is a interdisciplinary subject. It acts as a tool that according to your area of interest, if somebody is interested in forestry, a botanist will be interested in forestry, a geologist will be interested in species delineation, mapping, monitoring, the reasons behind animal human conflict, then habitat suitability, corridor mapping. Geologist will be more related to structural mineral explorations, landslides, floods, disasters. So for that you need a specialist, and for that you need a multi-dimensional knowledge in the field of GIS and remote sensing in order to get that satellite image interpreted, because that is not an easy task, because you're representing an object that you have not seen and you're stating about the object. So the accuracy depends on the amount of exposure and the data sets that you have handled in your previous past. Involves a considerable amount of subjective judgment, because many times, as we have already stated, that it is subjective, it's judgmental. That you'll see that the lands of Rajasthan are different from Bihar are different from Kashmir is different from Karnataka is different from Kerala. You're sitting in somewhere in Delhi and you're trying to, by seeing a satellite image, you're trying to identify the various earth objects. So many times you can misclassify or you can misjudge the area because you don't have a prior knowledge or experience and you're not familiar with. So always it is not fruitful. That's why verification is as equally important as image interpretation, because many times there are false figures or false triggers or false object will reflect a different object, and when you go to the field it's something different. So that's why field verification is very important in the field of remote sensing and GIS. So you always know that image is a pictorial representation of an object or a scene. Image can be analog or digital, it can be in hard copy, it can be a soft copy, it can be in the form of big maps. When you go into the field, you cannot carry laptop, maybe at many places you will have charging issues. So you take a printout of that area and go into the field, and you can match the area what you have mapped into the field, and you can check whether the accuracy of the data what you have mapped is of high accuracy, or what is the percentage of deviation that you're expecting for your map. A digital image is made up of square and rectangle areas called pixels. So whenever you see a satellite image, I've already shown, you will have a small square size shaped rectangular area that are nothing but spatial resolution, and the smallest unit of an image is known as pixel. So each pixel is associated with a value that is known as a digital number, and that depends on the amount of energy reflected from the ground. So if you've got a water body and if you've got a barren land, obviously the reflection of water will be on the lower side and the barren land will be on the higher side. So you can see that this is the way the satellite data are being recorded. So this is the various kinds of bands on which this sensor records on the various bands. This is the pixels with the digital number stating the various earth objects. In the same way, the information is gathered for the same area in different bands, and finally we prepare a composites on the basis of these bands to interpret the any area and to classify that satellite image. So you can see that how this red band, green band, blue band, infrared. So whenever you will see any band image is generally a single band image is a panchromatic image, and we do create a false color in composite using this existing band. At least three bands are required to get that false color composite generated. So now we know what is an image, what is a digital number, what is a pixel. Now how can you, or the methods through which you can classify a satellite image? It can be using visual method or it can be using digital method. They are the two methods you can, on the basis of which you can classify any satellite image, aerial photographs, or whatever data you are talking about in the field of remote sensing GIS. So under the category of visual interpretation can be subdivided into two major categories, that is visual interpretation on a hard copy image or a photograph, or visual image interpretation on a digital image. So there are two ways you can interpret a satellite image. Either you can take a A0 size maps are there printed by NRSC, National Remote Sensing Center situated at Secunderabad, uh, India, where the entire data sets what you get in the form of soft copy in disk or in through the data through server, the same thing you will get in a hard copy. So maybe many times you have to do in the ancient times or in the starting when remote sensing started, it was, and we used to manually map the entire features using the satellite images of the topographical sheet, and then they were scanned into the scanners and then transferred into the computer. Thereafter, again, the mapping was done to get that entire area or the map converted into digital form. But because that involves manual approach and a lot of errors was created while scanning, while transforming, while giving the positions. So instead of that, the best method is go and dig the satellite image digitally directly into your computer and go for your interpretation. But the other way around, the limitation of visual interpretation, it's very time consuming because maybe each and every pixel has to be done. You have to see, you have to have a understanding of the area, and then you will be classifying. So that takes lot of energy, lot of time, and lot of team is required. But on the other hand, if we use digital image processing techniques and we do digitally classify the satellite image, the amount of information that I'm taking will be very small duration. But the concern is the accuracy. Maybe many times the reflectance of the various Earth objects are nearly the same, like barren rock, riverine sand, many parts land without scrub. They have got the same reflectance. So if you are going with a classification technique with the help of tone, then maybe your area is misclassified. But nowadays, latest version of various sort computers are coming up where not only tone is taken into consideration for classification, but also texture, pattern, associations are also taken. So if you compare the classification accuracy with the tonal classified image, and then with the textural and tone, shape, size classified image, the accuracy is very high in that image if you compare with that of a tonal based classification. So that is equally important if you want to have a basic understanding of the area before doing any major project. Only the major features what are there in that area you can digitally classify, and it provides a good accuracy. So what makes interpretation of imagery more difficult than everyday visual interpretation of our surrounding? What are the things? We lose our sense of it when viewing a 2D image unless we can view it stereoscopically so as to stimulate the third dimension of the eye. So many times when we are seeing a satellite images, because we don't have the third dimension, so many of the features are misclassified because we don't get the real representation of the features what we are mapping it and how it will be situated on the space. So it's very tough to do that. Secondly, viewing objects from directly above also provides a very different perspective than what we are familiar with. So generally, when you're seeing an object from the top and when you're seeing object vertically, many times the perception, the understanding get confused, and you don't feel like you what this object is all about. So that can create a confusion, and at last this all confusion will result in poor accuracy of the maps. So combining an unfamiliar perspective with a very different scale and lack of recognizable detail can make even the most familiar object unrecognizable in many. So many times you will see that while digitizing and while classification and you're providing the attribute to those odd features, you'll do blunders and silly mistake that you will be laughing on yourself that how did it happen. So it happens many times. So we have already studied that we have to look for that before doing any kind of analysis image, you must always see about the spectral resolution, about the bands, radiometric, about the smaller differences of energy that can be measured, than smallest unit area that can be measured. Then you have got revisit the total time between two consecutive image acquisition of an area. So this is all about the various kinds of resolution. How with the change in resolution from 80 meter to 10 meter, the amount of information in any images get in detail, and that will increase the accuracy of the classification. The same is for the spectral bands. If the number of bands are high, the amount of information to differentiate between the various bands will be high, and we can have a more greater spectral response curve created for each and every feature, and we'll be able to differentiate the various earth object efficiently. The same is the color combination. If you see with the 2 level data and the 16 level data in the given satellite image, the 16 level data provides you greater visibility by boundary, shape, size, texture, association, because you have got 15 colors to play with, whereas in 2 level data only you have got black and white. So if you go there, the difficulty of interpretation is too high. And the same is for the revisit time, that if you want to have some temporal analysis of that area, the revisit time is very important to get that information done in real sense. So, what are the advantages of remote sensing over the ground board observation? That the first advantage is it provides a synoptic overview, means a large area can be seen on a single point of go in your laptop, and you can have a real understanding. But if you, I went into send you in the field, you cannot even see 100-meter objects in and around because of our visibility. So that gives a better understanding of the area, and over the decade, if you want to see the changes, that can be easily noticed and mapped and evaluated, and we can model it for our future models. Then because that is more covering more area with the real information, means that is saving our time, saving our energy, so it's time saving. Then it's a permanent record of that region, that from 1970 till date we have got the series of satellites that are available and stored in our databases. So if we want to do any kind of studies that is historical in nature, then we want a specific point data of that region, we can go and we can evaluate that. Then next is spectral resolution, denotes to the various bands that are available in, and that helps us to identify the various earth object. The same is for the spatial resolution. Even the finest amount of object details, we can go for high resolutions mapping and feature. And this is cost and time effective. This is very efficient, time saving, money saving, and it saves the time. Many times it provides a stereoscopic view, that is it's have a 3D dimension of that terrain, and we can have a stereoscopic view, and that brings out the relationship between the objects. Then type of interpretation, you have both type of interpretation, qualitative and quantitative. So both are the qualitative and quantitative. What are the principles of image interpretation? So principles is image is the pictorial representation of the pattern of the landscape. The pattern indicates types of objects and their physical, biological, and cultural relationships. Similar objects under different similar conditions reflect similarity. A systematic examination of footings and supporting material. Interpretation is made of physical nature of the object. Information extracted is proportional to knowledge, skill, and expertise of the analyst, and the methods and equipment used. These are the various methods, principles that you have to be applying. What are the factors governing interpretability? That depends on the training of the data sets, what kind of training the analyst has done, and what is the kind of experience do we have for such kind of training. Then nature of the objects or phenomena, what are the kind of objects or the phenomena we have. Then the quality of the photograph that we are looking for, what are the quality whether there does not have any fog or cloud in the image, because that do covers the entire information of the image. Then equipments and the methods of interpretation. What are the kinds of equipments and the methods that we are using it to increase our accuracy of the map? Apart from this, we have to check for the interpretation keys, guides, manuals, and other aids, that the reference material that the interpreter is looking into, reading into. Because directly by seeing a satellite image, if you go forward and without having the basic understanding of that area, the amount, maybe you can classify the image, but the amount of accuracy of the map will be not so high. That's why always it's important to read about that area prior to going into the field, so that you can have a real understanding of that area and you will have a prior knowledge of that area. So the methodology depends on kind of information that has to be, information has to be interpreted. So what kind of information is required, whether the you are requiring at a district level, at a block level, at a village level, at a state level, or a country level. So depending on that, depending on the satellite images, depending on the spatial resolution, spectral resolution, the accuracy of the results vary from center to center and from analyst to analyst. The reference level of a person executing the information is very important, because if an interpreter doesn't have a real understanding of the terrain, doesn't understand the terrain, so many times he'll be misclassifying and he'll be providing misinformation, and that will greatly hamper the result of the project. So other parameters that are equally important are the kind and the type of imagery or the photographs that are available. So you have to check for the kinds of images, what kinds of images are available, what types of images you want, what kind of instruments are available with you, what are the scales and then the requirements for final map generation. Apart from that, external knowledgeable available ancillary data, survey data. So you require various kinds of data sets, because the more you read, the more you survey for the data, it will be easier for you to understand the terrain and get your area map properly with a higher percentage of accuracy. So what are the activities through which we can do? We can do detection. What is the change in land use, land cover area over the detection? Then you've got recognition. You're recognizing what new features have come up, whether that is of damaging towards the environment, whether that has got a positive side, whether that has got a negative side. So all such analysis will be performed, and finally we'll be putting some new indices, we'll be putting some new methodology and model to get your data classified and producing a high resolution maps and images of the area, and on the basis of which the decision support users will be making decisions on that area, what kind of development activity has to be performed in that area, and finally on the basis of this the users will be benefited. So data selection criteria depends on your objective, whether you want a satellite image or whether you want a drone image, whether you want to go for a high spectral resolution image, or whether you need a high spatial resolution, what are the kind of time interval that is required. Well, all depends on your application and objective. That varies from image to image, that varies from person to person. So as we have already stated, there are various elements of image interpretation, and for recognizing those keys, those elements, those parameters are very important to get that object identified on the satellite image. So what are those keys? Like each and every lock has got a key. In the same way, these keys, if you have got a basic and a better understanding of this key, you will be easily identifying all earth objects that you see on any satellite images, and that are tone, texture, shape, size, pattern, association, shadow. So they are the various keys on the basis of which you will be identifying the satellite image. So we'll start up with one by one. We'll be starting each and every key. We'll start up with tone. Tone is the color what we are talking about. So tone refers to the relative brightness or the color of an object. Generally told is the fundamental object for distinguishing between different targets or features. Like if you see for banana, if you see for mangoes, if you see for pineapple, if you see for oranges, apples, all have a different shape and color. So on the basis of color, we'll be identifying different earth objects. Like fruits we are identifying in the market, in the same way, on the basis of color, we'll be identifying the various earth objects. The variation in tones also allows the elements of shape, texture, pattern to be distinguished. So, not only help us to identify, but it also aid us in the shape, texture analysis of a particular pattern. Next is to identify any satellite image. We also do take help of, like, if I say more example of tone is the water body. If I go for different kinds of water body that is seen in a satellite image, you'll see the satellite images ranging from black to blue in color. So what does this black and what does this blue color indicate? Black indicates that the water is stagnant, it has got a greater depth, and it's not a flowing water. Because in flowing water you will have sediments, and sediments will scatter the low or the nearest bands in electromagnetic radiation. Therefore you will be seeing blue in color with the sediment content is high in river, and black denotes that the sediments are settled down at the basements. So that's why many times on the basis of which we can identify the depth and the area coverage of river water bodies. In the same way, shape refers to the general form, structure, or outline of an individual body. Like shape, if we see the shape of a camel and an elephant, by seeing the shape, we identify that this is a camel and that is elephant, because from my childhood we have been given a diagram where the shape of camel and shape of elephant was shown. Ki this is the shape how elephants look, this is the shape how camels look. In the same way, in the satellite also there are various shapes that has to be identified, and if we identify those shapes, you can identify easily the objects we are trying to identify. So straight edge shapes typically represents urban or agricultural field. So generally, if you've got a straight edges, you'll be it is generally towards the, that is also known as bonds in India, and that you won't find in forest areas or forest land, that is regional in nature. And the small bonds are rectangular in nature. So if the both objects have got same color, so how to differentiate what is forest and what is agricultural land if they both are showing red in color because of the false color composite? Then we'll take shape of the object to identify that in agricultural land you will have more kind of bonds with a rectangular pattern in and around your got a settlement area, roads will be connected. So this all are association apart from shape that we are taking for recognition of that object. And in the forest, that will be regional in nature, less of settlement, less of connectivity, so we can say that is a forested area. So in such a way, you will to be seeing that in the forest the regular areas are not there, then roads connectivity is less. So such features has to be identified, has to be sourced prior to coming to conclude what that area, what that class is. So farm or crop land irrigated by rotating sprinkler system would appear as a circular shape. So you can see that this in between you have got a sprinkle and there is a water that has been sprinkled. This is more common in Rajasthan, so you can easily identify and usually see what that object is. Next, that object depends on the size of the object. We have done with shape. Now the size depends on the scale. So it is important to assess the size of the target relative to other object in a scene, as well as the absolute size to aid in the interpretation of that target. A quick approximation of the target size can direct interpretation to an appropriate result more accurately. So if you see the size, for example, if an interpreter has to distinguish zone of land use, he had identified an area with number of buildings in it. So large buildings such as factories or warehouse would suggest commercial properties, whereas small building will indicate residential properties. So in the current satellite image, you can see that there are small buildings on the lower south and northeast, and in between you have seen big houses constructed with a larger, broader area. That suggests that by saying this, can say that the small buildings are well connected with for plantation. The road connectivity is good, and in between, by seeing the size, you can see that this area is looking like a warehouse or industries. So by seeing the size, we can also easily identify the various kinds of buildings, their properties. In the same way, the other keys that is used for image interpretation is pattern. So pattern refers to the spatial arrangement of visibility of the described object. So what does it typically do? It is typically an orderly representation of the similar tone and texture will produce a distinctive and ultimately a recognizable pattern. Means will show the same. If you see this and you compare with the water, you'll say that water gives a more smooth. Smooth means low spatial frequency, and rough means high spatial frequency, that we have already known. So orchards with evenly spaced tree and urban streets with regularly spaced half are good pattern of examples of pattern. So many times, if you by seeing a pattern, you can see this pattern and you can say that this is a residential pattern because they have got fixed pattern, means repetition of the object that is used for identification of that object. Then refers to texture. Texture refers to arrangement and frequency of tonal variation in particular area of an image. Means texture is an important element in distinguishing feature in the radar image, where the rough texture will consist of motile tone, where the gray level change is roughly in small areas, whereas smooth texture have very little tone variation. So as you can see, the scheme that total variation is very high in rough texture and less in smooth texture. Then shadow. Shadow may provide an idea of the profile and relative height of a target or targets which could make identification easier. However, shadows can also reduce or eliminate interpretation in their area of influence, since target within shadows are much less distinguished from their buildings. So we can easily identify those buildings. Then association takes into the account of the relationship between the recognizable objects of features in proximity to the target of interest. The identification of features that would expect to associate with other features may provide information to facilitate the identification. So commercial properties may be associated with the proximity to major transportation routes, whereas residential areas will be associated with schools, playgrounds, and sports fields. So many times you have to see the association, where you are located, what are the features that are like in an agricultural field. From the main river there is a straight line coming up and passing through the agricultural field, and then it is going and meeting to the another river, means that that is not a railway line, that is not a road line, but that is a canal feature. So we identified those because that has passed through the agriculture field that is connected to a river. So we said because it is not going beyond the river and it is ending up into the river. So neither the road, neither the railway will be ending up into a river and starting from a river. So that is a canal, not railways and roads, because all the trees look like same in your satellite image. So these are the association that will be taken into consideration before classifying the satellite image. So you can have various kinds of satellite images that are available with you. You can have a stereo analysis, means 3D imagery. 3D satellite images are available where you can do 3D kinds of measurements. Then you have got multi-band images where you have got various bands are taken into consideration for classification of that object. Then you have got multi-date, that is from 1950 70 onwards. We have got the satellite series available with us. Prior to that, we have got topographical sheets from 1925 onwards, and other secondary data published in various state and government agency in the form of reports can be taken for the historical understanding of the area. And multi-stage is like, yeah, we have already stated yesterday that there are various kinds of platforms available, whether that is a ground-borne platform or a airborne platform or space-borne platform. That all depends on the objectivity, that which kind of platform, which kind of data, whether you will be going for optical data or a microwave data or hyperspectral data. So, image interpretation for multispectral data that we generally do, like we are doing talking about least 3, least 4, or Landsat TM or ATM plus. So that depends on the resolution. What is the resolution of this image? Then stereoscopic ability, individual band interpretation, and the temporal visit of that satellite. Then sensors in photographical image interpretation, but you've got different kinds of sensors. You can get a black and white image, you've got a black and white infrared image, you can color image, you can get a color infrared image, you can color infrared false color image. So you have got various kinds of options that are available with us for identification of those earth objects. So this is a aerial photograph stating the black and white image. Black and white image denotes panchromatic image, what we are seeing right now. So in the upper right corner there is a hydrofoil ship, and the other big ship is tanker delivering fresh water to the islands. So you can see by seeing the pattern, by seeing the association color, now we know what kind of ships are moving in that water. The same is color and false color. On the left hand side it's true color, on the right hand side it's a false color. For a normal color, the layer are sensitive to blue, green and red, the same to our eyes. So whatever we see, it will be seen reflected in a natural color or a true color. But accordingly, these photographs appear in the same way that ours see in the environment. So on the left hand side, what we see is the same that is been mapped by the satellite images, but the color resemble those which would appear as normal trees appears green. Okay, so you can see this is a false color and this is a true color. So then this is the satellite image that is used, mid infrared image of Stromboli Island, then Landsat image of Boston. You can see this the dark area is denoting to the water bodies, and that too the sediment content is not too high in that river. It's having a high depth too. That's why it's black in color. And along the boundaries of this, you will be finding various airports, urban areas, and as in between, you will be seeing this black. This all are water bodies, and in between, you are seeing various kinds of red in color. They are the various with a specific shape and size. Means that is not a forested area, not a planted area, because we don't see any plantation. So maybe they are the various kinds of agriculture activities that they are doing. So again, this is a satellite image where you can see that the meanders are the important characteristics to identify the earth object. So by seeing this, we can say, okay, this is a meander, and meanders are generally associated with rivers, with the color, shape, size, association flowing along agricultural land. So on the basis of that, we'll be classifying this as a river. In the same way, by seeing a satellite image, we can see that that has got a specific shape, size, color. That's why we'll say this area is agricultural land. and in between there is no vegetation, and along the rivers that are giving, we can say these areas are unutilized, means they are maybe land with scrub. Then circular feature indicates a sprinkler irrigation system. So you can see that this kind of, whenever you will see that such kind of things are there, that indicates of sprinkle. Red color indicates crop, and dark color indicates fallow land. So this is a sprinkler irrigation system of Saudi Arabia. Then multispectral shows the areas of Goa state. Rewards, red patches represent densely vegetated area, airport in the township. So you can see this, all airports, township, vegetations, all can be easily mapped using this satellite remote sensing data sets. Then you have got this Sundarban Delta. The image shows east coast of India, and Sundarban water is shallow water near the coast are seen. That's why it's light blue in color. The mangroves are seen in bright red color in the wetland area, bright red, and the rivers Hooghly dispersing sediments into the sea can be seen clearly. So this is a Hooghly river dispersing all the sediments. This is Gulf of Oman. The mountain and rocky terrain of the area is through seen whiffs. So you can see all these monkey terrains. Then the images of Dhaka city showing the stadium and airport clearly. So you can see this is a airport. In between you will be finding this regular round shape stadiums. Then in between you have got settlement somewhere. It is properly arranged a residential area that is well organized. Somewhere it's congested. Then somewhere you can see slums. In between you are seeing the various water bodies available in that area. Then this image is of Rome. The runway shaped can be seen. So you can see the runway shape, how the runway shape. In between you can see the agricultural land that has got fixed shape and size, and adjoining that you can see the fallow lands that maybe in the current season there is no kind of cultivation going on, but maybe in the other season you will have various kinds of cultivation. And you have got various road, railways, connectivity that can be easily identified upon from the settlement areas. Then somewhere some minings are going on. So that are the various kinds of features that you can identify. Then road, rivers, water body, topography, and urban area can be all distinguished. So you can see this a river, then vegetation, then in between settlement. So all can be easily identified. So you can see that this is a 1 meter resolution of Pentagon collected on 7 2001 by imaging Icono satellite data, and only 4 days before the terrorist attack done. So you can see that how well this is, and after a terrorist attack, you can see what is the damage that has been done in that area. So you can have a pre and post analysis of the area, and the damage assessment can be done. So you can see that the entrance, there is a lot of damage that has been done. The satellite image of was collected at 11:40 same ED on September 2, 2001. So by Econo satellites, the image show extensive damage to the western and interior rings of the multi-rung building. Also visible are the emergency and rescue vehicle parked along the helipad. So you can see that how the vehicles here, these vehicles are parked along these helipads. Getting it? At the outskirts, at the outways. So this is all agricultural land that you are seeing. In between you see this is the plantation, because that is showing a particular shape and size. That's why that is not agricultural land. Then you have got nuclear facility, that is a pan-shaft multispectral resolution. So you can see this. Then these are the sand dunes that we have already stated. Sand dunes again, deserted area. Then these are various mountains, rocks, divide of vegetation. As we cannot see in between, you can see the various structures. So using this satellite image will be a great help to a geologist or soil expert, so that we can go and we can see the sites where we can go for groundwater exploration exploitation. The same is for the persons who are working in the field of glaciology, so that they can get a real time information of the entire terrain, because whatever satellite image right now is showing us, through this we can suggest whether the glaciers in the Himalayas are melting or not. That will be providing a clear understanding. Otherwise, nobody cannot go into the field. So the only thing that can go and we can have a quantitative and quantitative measurement of glaciers is only through satellite remote sensing, where this white color in the current image is representative of representations of glaciers. So the glacier area can be easily differentiated from the other hilly terrain and the mountain terrain. But many times when you're classifying a glaciers, there you can face the problem of clouds, and these clouds are nothing but hindrance, and they do absorb the information beneath it what they are coming up. So there are various operation in digital image processing through which we'll be masking them out and will be creating a better geo rectified and radially rectified satellite images. So these are the features. Then this is the residential building, how it look like. So it's more kind of a slum congested, but here if you see that, you can see this is a well organized located buildings with a 3D perception. So we can, by measuring the height of the shadow, we can measure the height of the buildings. All such analysis can be done without going into the field. Recently you've seen there was a lot of fight between going between Palestine and Israel. They used Israel used to locate the strategic location of the persons who were involved for conspiracy against that country, and they used to locate that area and they used to bombard. So that was possible only using remote sensing and GIS, where the exact locationing of that area can be done. In the same way, this is the railway track, where you can see that a large number of railways are standing and moving. So it can be easily identified. Such figures can be easily. This is the various runways and various highways, yeah, how they are connected towards each other. What is the condition of traffic? Whether there is any kind of traffic congestion. All such information can be assessed and can be directed in time. So, what is the conclusion? That manual interpretation and analysis was back to early beginnings of remote sensing using aerial photograph. Manual interpretation requires little specialized equipments. Manual interpretation is often limited to analyzing only single channel of data. Manual interpretation is subjective in nature, meaning the results will vary depending on the interpreter. In digital image processing, analysis is more recent, advanced, and that is based on computer. Digital analysis required specialized computers, specialized softwares, and that is costly in nature. The computer environment is more amendment to handle complex images of several many channels from several data sets, and that is very easy. The computer can easily handling the data sets, but manually it's quite tough to handle the data sets. The digital analysis is based on the manipulation of digital numbers in a computer and research objective, generally resulting in more consistent results. However, determining the validity and accuracy of the results from distinct processing can be difficult. The accuracy is the biggest concern. Otherwise, it's the best method to perform any kind of classification or interpretation from satellite images. So it's important to reiterate that visual and digital analysis of remote sensing are not mutually exclusive. In most cases, a mix of both methods is usually applied when analyzing a satellite imaging. An ultimate decision of the utility and relevance of the information is extracted at the end of the analysis. Still must be made by human. That's why we, the human being, are the biggest boss of this universe, because all the software, all the equipments depends on our command and depends on our mood. So with this I have completed the various keys and what are the merits and what are the demerits, and what finally we can conclude with the entire operation, which is the better mechanism of classifying a image. So both has its merits and demerits. So depending on your objectivity, depending your intensification, depending on your budget, depending on your manpower, depending on your time, you will be selecting the appropriate interpretation technique for classifying the various satellite images. So with this, I will like to conclude my today's presentation. Thereafter, we'll have a 10 minutes of quiz and questionnaire, and thereafter we'll conclude the session. So, okay for today. Stop.